Well, good evening and welcome to Environmental Coffee House. This is Sandy Shellis, and I am going to be introducing Jennifer Hynes and Jim Massa. Hopefully, our internet connections will be okay tonight. We're hoping. So, Jennifer, I'm going to bring you up first. Good evening, Jennifer. How are you? And we'll be
I'm
welcoming.
doing great
This is
tonight, Sandy. Thanks so much. I'm
awesome.
excited to be here. I
We've
think we
got a
have a
lot of
great lineup tonight.
We do. If the
Yeah.
internet stays going, it will be wonderful. Let me pull up Jim. Hi, everybody out there, Kim and Garrett and Dee Dee and Gary. Let's hope. And if Jim doesn't show up, he's here. Jim, why don't you say hi?
Hello, everyone.
Okay,
Good
I'm
to be
going
here.
to leave. He's there. So, welcome, you guys. I am going to leave the show to you. And I am going to just give it over to Jennifer tonight and be behind the scenes, which is fine with me. So you guys enjoy, and I will. I am just having such a day today. So I'm leaving. Farewell.
Farewell, be well, and we shall see you behind the scenes there. Guys, we've got a fabulous show lined up tonight with loads of current events. The first thing we're going to be covering is a tweet that Zach Labe put out. He put it out on October 9th, and this is about the laptive sea ice and how it's not refreezing. So that's pretty fascinating. We're going to spend some time on that. Then we're going to cover an article that came out recently on October 6th in Yale Climate Connections. And it says bleak views of melting Antarctic ice from above and below. Two troubling recent studies clarify projections of sea level rise, need to act on climate. So, Antarctica and what's happening there. And then we're going to talk about California, turn our mind to the California wildfires. And this one recently came out in The Guardian and came out on October 6th also. And there's a new term. It's called the gigafire. So this is the title. California wildfires spawn first gigafire in modern history. August complex fire expanded beyond 1 million acres, elevating it from mere megafire to a new classification, gigafire, never before used, brand new term. Then we are going to finish up with an article from, looks like Mike, MMIC.com, and it's about Exxon. Might make you a little bit mad, but it's good to know about these things. Exxon is planning to pollute way more in the coming years, leaked documents show. So this is probably not a huge surprise, but yet again, another instance of how the petroleum industry is so committed to burning every blessed last little bit of petroleum that they can find. And this came out on October 5th. So Jim, I'm thrilled to be able to work with you tonight and present with you tonight to talk about these interesting articles. How are you doing
I'm
tonight?
doing well, and it should be some interesting discussions uh, that will happen tonight.
Yeah, yeah, absolutely. The first one that I want to talk about that we discussed is this tweet from Zach Labe. And Sandy, if you could bring up the full chart of that laptive sea ice graph. So the white is the August 1981 to 2010 average. The lighter white is the one standard deviation. The grayer color is two standard deviations. The bright blue is 2012 cycle in the laptive sea, and the red is us. So, you know, this is like off the charts. This is stunning. You can see there hasn't been even sea ice in the Laptev Sea since September of this year. It's just freaking flatlined. What do you think of this graph, Jim? What do you think of this?
It shows us that the Arctic Ocean is changing dramatically. And this is the Laptev. If we go around the Arctic basin, we see similar things. I mean, if you look at the overall Arctic, 2020 this year is overall. That includes, the Beaufort, the Chukchi, the Laptev, the Kara, East Siberian Sea, Barents Sea, etc. 2020 is the second lowest ever. 2012, the blue line here, so far is the lowest ever, and it reached the lowest ever, as you can see, kind of right there in the middle of September of that year.
Yeah.
But looking at the Laptev, basically what this is telling us, as you just said, there is zero ice there at all.
Yes.
Which means that is a lot of solar energy being absorbed by the water. Even though now we're on the other side of equinox, so the tilt of the planet is now further away, you still have open water. It's still, you're still having about 10 hours or so of daylight. It's still going to be absorbing some heat energy, even if it is indirectly and may not be as high as a joules per square meter, but nevertheless, energy is still being absorbed. So it will delay the cooling down sufficiently that you may not see ice forming until the end of October, early November in that region, which has dramatic major consequences.
It does. It does. And another thing that a lot of us are aware of here is that this is on the Siberian Arctic shelf. This is a huge area of fairly recently, within like the last 10,000 years or so, submerged terrestrial permafrost. And as the ice age ended, and the sea levels rose about 400 feet, between 14,000 and 10,000 or 6,000 years ago. This was submerged, and it is full of biological material and also methane hydrate. What do you think the likelihood is that we're going to have some sort of methane event, or are we currently having a methane event underway?
Yes, to all. I mean, we're seeing methane leaking out, whether it's from the clathrates, the hydrates, the permafrost. We're seeing it. It's being measured as we speak. The question is how much total methane is locked up in all the grounds, hydrates, clathrates, permafrost, and so on. So they're trying to get a handle on the total amount that's buried, and we're trying to get a handle on at what rate will it be released. We're seeing the release now. The big concern, this is what keeps the climatologists up at night, is will there be an event like as you discussed before, a methane time bomb? Will there be such an event where there's a sudden, and we jokingly, kind of a sardonic way, basically call it a methane burp or fart? And will there be a massive release of this methane? And if so, that is just going to have really, really terrible consequences.
Yes. Well, that's been a topic of some controversy, because some people say there's a lot of methane hydrate to be thawed out and come directly into the atmosphere, as the Siberian Arctic shelf is only about an average of 60 meters deep. But some people say that not so much, that this is not really a threat. Where do you fall in that, Jim?
Well, it's like everything else. Depending on the sampling methods and the analytical methods, you're going to see a wide range of opinions on the actual estimates. I defer to Igor and Natalia, to be quite honest, because they've been doing this for decades. Igor has now moved over to the terrestrial end of things, while Natalia continues working on the shelf issue in the Arctic Ocean. And I'm more inclined to go with Natalia estimates, not because I know her or whatever, but because she does damn good work. You know?
Mm-hmm.
And her what she has put forth as estimates is basically being borne out. So I said I'm going to defer to her because of her expertise and the experience she has and how long she's been doing this.
Absolutely. So what's her take on this? Most of us realize what she says, but what does she say?
She thinks it's a major problem. She thinks there is a methane bomb waiting to go off.
Mm-hmm.
Now she's trying
Yeah, I
to,
tend to.
of course, there's always going to be some errors and quite a few bit of errors associated with such measurement. So she is trying to get an estimate of how many gigatons is in the hydrates, just like Igor is trying to estimate how many gigatons in the permafrost.
Mm-hmm. Yeah.
And
Well, it
notice
ain't
we're
good.
talking, notice we're talking gigatons, so that means there is a lot.
There's a lot. And it's probably going to go directly into the atmosphere because I think that water column can only absorb so much. There is a maximum amount that the water column of 60 meters or so can absorb. And after that, it's not going to continue to absorb anymore, right? I mean, it's just going to like go right up. That's kind of
Well,
what
the
I would think.
keep in mind the methane is mostly the result of biological activity, decay and that sort of stuff. Now, colder water can hold a higher uh, level of gases. Basically, gas
Right.
solubility does increase with a decrease in water temperature. So, to reach saturation will be a higher level because of the colder water. You warm up the water, and then you're gonna have the reverse situation. So we have to see, but we are already seeing bubbling right out of the sediments.
Yeah.
I know for a couple years ago, some Norwegian researchers were filming methane bubbling out of somewhere in the northeast Atlantic. Like around near Franz Josef Land, something like that. There, in that area, they were filming. Here's all this methane bubbles coming right out of the ground and just going right up to the surface.
Yeah.
And don't forget, here's the other thing: is okay. So you have this now. Granted, it's 60 meters. You know, 60 meters is close. Is a little less than my personal deepest dive I've ever did on scuba, but it's still
Mm-hmm.
down there, and it's still a bit of pressure. So, increase the pressure, you decrease the volume. So it's kind of deceptive saying, oh, I might have, say, 100 mils of a gas.
Mm-hmm.
That's at pressure. You reduce the pressure on a thing, that 100 mils is going to expand to maybe 1,000 or 10,000 mils. It's depending
That's
how far
right.
deep it came down from. So as the gas
That's
starts
right.
moving up the water column, it is expanding. So it's actually going to be more gas that's end up being released. I mean, just if you ever scuba dive, just look at your bubbles as they go up to the surface. They just get bigger and bigger.
Yes, they do. They do indeed. And that's kind of what happens when methane goes from the solid state with methane hydrate, clathrate, into the gaseous state of pure methane. When it thaws, essentially, I believe it's like molecule for molecule about 186 times difference between when it's in solid state and when it's in the gaseous state. Hence, that's why those pingos are rising up in the Siberian permafrost and also in the Canadian permafrost and other places as well. And they're popping up like pimples of the earth with a really bad case of acne and
Yeah.
eventually exploding if enough methane, under pressure coming out at the same time.
And keep in mind also that as the methane is bubbling, through the water column, yes, we're seeing the bubbles, but there's still in addition to the bubble, there's still some methane rising that's still staying in solution, still dissolved in the water column. So yeah, we see the gaseous bubbles, but there's probably also methane in solution following that up right there with it. And then it hits the ocean air interface and can get released into the atmosphere as well.
Absolutely. Well, with that, I mean, we can see that the Arctic and everything around there is melting really fast. I think we should turn our attention to our second article, Sandy, the one from Yale
If I
Climate.
can make just one last point about the lab test article, the diagram there. You can see that what's happening to the lab test sea ice is well outside 2 standard deviations. In fact, it started to be well outside 2 standard deviation before the end of June. So this is significant. So this is basically saying the probability of this being due to random situations in nature is extremely low. In fact, it's less than basically 5%. Just to point that out.
That should, I mean, that's the obvious thing that we forgot to mention. This thing is gone off the charts. It's flatlining. There is no ice in the Laptev Sea, period. Here in the middle of almost October, unheard of, has never happened. This is historical. This is faster than previously expected. All of that. Definitely. This is serious stuff. And I'm glad that you called us back to this to just further emphasize how abnormal this is.
Yeah. It's important for people to see that, and that's why I like that that Zach is making these graphics now, including the statistics, so you can see at a snapshot, how things compare and stack up to the overall trend. And by the way, I want to mention something else. They're looking at the average of 81 to 2010, so that's basically a 30-year average. When 2021 rolls around, everything's going to be recalculated from a 1991 to 2020 average.
You don't say.
So they're doing a 30-year running average.
You can't keep a firm grasp on reality because they keep redefining the baseline. It drives me up the wall. It really does.
It's running averages. It's a common thing we do here. We just do running averages all the time.
Yeah.
And for some reason, meteorologists settled on a 30-year thing.
Well, okay, fine.
But you see, the thing is, I mean, you can do a comparison to 30, 50, 100, whatever, 150 years, and those things are done. The bigger you make the time interval, the less details you will see in the information. Whereas you shorten the time interval, you can pick up on more details. So oftentimes in a published paper, you will see, compares to this 30-year average. It compares to this 50 to 100-year average. So they do the different parsing out, and you can then see how it's compared to 100 years ago, 50 years ago, etc. So a lot of it depends on how much detail you want to discuss or illustrate, or if you're just looking more of a general trend. So both are done when in a paper, in a peer-reviewed paper.
Yeah. Well said. Thanks for bringing our attention to that. What do you say we move over to the Yale Climate Connections article now in Antarctica? Bleak views of melting Antarctic sea ice from above and below. 2 troubling recent studies clarify projections of sea level rise need to act on climate. So I'm just going to read a couple of paragraphs to give the flavor of this article, get us into it, and then we'll have a little discussion about it. Images from satellites high above the Earth have helped a research team put together a stark visual chronicle of decades of glacier disintegration in Antarctica. Meanwhile, a separate international research team has taken the opposite perspective, studying the ice from its underbelly. Both teams are documenting the stress on two glaciers in West Antarctica that so far have helped check massive stream of melting ice responsible for about 5% of Earth's rising sea levels. Climate researchers have long monitored ice sheet dynamics in the Andalusian Sea. Did I say that right? Andalusian Sea. Focusing specifically on the Thwaites and Pine Island glaciers. The two sit side by side on the Antarctic Western Peninsula, covering an area roughly the size of 9 U.S. coastal states stretching from Maine to Maryland. That's a big area. The two glaciers alone store ice that could account for about 4 feet of global sea level rise. Their seaboard locations may help bring an increased public attention and interest to West Antarctic ice sheet, which, if melted, could raise sea by a catastrophic 11 feet. An international effort led by the British Antarctic Survey recently published 2 papers showing the first detailed maps of the sea floor at the edge of the Thwaites Glacier. The team mapped deep submarine channels that have been funneling warm water into this vulnerable location. Wow. High-resolution imagery pinpoints the pathways that allow warm water to undermine the ice shelf. Lead author Kelly Hogan of the British Antarctic Survey says the findings will improve estimates of sea level rise from the Thwaites Glacier. Quote, "We can't go ahead and make those calculations about how much warm water can get under the ice and melt it," Hogan said. The other researchers, led by Steph Lerma, found a visual confirmation of glacier disintegration using decades of time-lapse imagery, just like in Chasing Ice. Their work sheds light on accelerating feedback processes wherein the rapid loss of ice is opening the door to ever-increasing melting. Wow, this is a stunner, Jim. And this has got a lot about the melting from below and warm water, volumes of warm water tunneling and channeling their way underneath the glacier into cavities below. This is a pretty stunning article. What is your take on what's going on in Western Antarctica?
Well, this is a situation that I have discussed quite extensively on my channel, and I can't say I'm surprised. It's just because it's physics, but it does not detract from how serious a problem this is, because when you have the glaciers, okay, you have some of the glacier that's grounded, so it's sitting on the bedrock, but a lot of the glacier also extends out, actually out over the ocean. So now you don't have bedrock underlying it. So it's almost like a cantilevered, flooring and that kind of stuff there. So now what they did not say, and what goes with this, is the loss of sea ice around Antarctica. So if you're losing the sea ice around Antarctica, so you're going to have the open water situation there as well. So that open water is absorbing sunlight energy, which gives warmer current that can now keep flowing underneath the ice and erode the ice from that location. So tied into this is the loss of sea ice around the Antarctic continent itself.
No, so true, so true. And this glacial intrusion of warm water, it's not limited strictly to Western Antarctica. Eastern Antarctica on the Totten Glacier, that has it's kind of on the decline. And so the warm water tends to channel under the Totten Glacier at the volume of about 30 Amazon rivers. That hot water is flowing inside the glacier on the Totten Glacier in East Antarctica. One of the biggest glaciers there are in East Antarctica as well.
Yeah,
This
that's that.
situation with Antarctica is just like pervasive, don't you think?
Yeah, and that's a very good point to bring up there. Also, you have the Ross Shelf, you have the Brunt ice shelf that is also under threat of Antarctica. It's kind of what's out there on the peninsula, so that juts out a little further into the Southern Ocean. But still, that's in threatened as well. So when we see the approximately 3 to 5 meter estimated rise, that's just from these two glaciers. It doesn't take into account the rest of Antarctica if that were to all melt and fill up the sea levels. So there's a big serious issue going on here. Um, yeah, we have warm water. It's just eating away, and eventually what happens is you weaken the ice to the point where it just simply cracks and snaps off, and then the currents take it away. The currents move it into warmer, latitudes. It melts.
Yeah. And Antarctica has been a lot in the news lately as far as melting events. There's been a lot of extreme melting in West Antarctica and also in East Antarctica. And there's probably between the like Thwaites Glacier and the Pine Island Glacier, they say there's about 11 foot of sea level rise wrapped up into that. Is that your understanding as well? Or is
Right.
it greater than that?
That's kind of the estimates I'm seeing is 3 to 5 meters. So 11 feet, which is 3.4 meters, is within that range. Maybe perhaps on the lower end, whatever, but it's still within that range. Um, so yeah, that's based. You calculate the volume estimated, and then you do your calculations to what that would translate to if that all melted and was added to the oceans. So it's
How fast do you think that this tremendous breakdown between the Pine Island and the Thwaites is going to happen? Do you have any feeling for that?
well. The thing is, the key, at least over there on the western side, is Thwaites, because if that gives way, and is concerned that that could happen imminently, like within a couple of years, is what I'm seeing now. If that lets loose, Pine Island is like it's closely following right behind it.
And
So
the Ross Ice Shelf is in there too, somewhere?
that has its own situation, and we've seen the images of massive icebergs breaking off from there. So the physics is about the same with the underlying warmer waters there. It is not unreasonable to expect Ross to also collapse. I mean, that's just what's going on. But yeah, the Thwaites is. I just saw some recent articles. Some recent publications that the concern is that this is extremely unstable and could let loose at any moment.
Oh my goodness, that's really scary. Well, we'll have to stay tuned and keep watching this area very, very carefully.
But here's the other thing: where people say, "Oh, when the sea levels rise, okay, how much of the coast is going to be not habitable anymore?" It's not just the coast. People need to keep in mind that you have major rivers feeding into whatever body of ocean, so on. Let's take the Mississippi as an example. Sea levels rise, you're going to have seawater, flowing right up the Mississippi Valley, filling that in.
Ugh.
So now you've got water that's no longer at 4 parts per thousand salinity, which is what potable drinking water is, 4 parts. Now you're going to have water that's, say 15 to 30 parts flowing in. It's still not drinkable. It will still ruin the crops. Don't forget, during the Jurassic era, the continent of North America, that's when sea levels were higher, the continent of North America was basically bifurcated. The inland ocean in the middle of the continent,
And
right
when
all
was
the way
the
up into
last
Canada.
When was the last time that we actively had an inland sea in North America?
I don't know offhand. It's probably during the Cenozoic. You know,
Yeah,
yeah.
but
I mean, there
but
was.
I see evidence of it here in Colorado because the shores of the inland sea came right up here to the Rocky Mountains, and you can see how the buttes are carved and things like that. And the inland sea was very much here. And you can see like sea creatures, fossilized sea creatures here
Oh,
in the
you
rock.
see the same thing in if you go to the Sangre de Cristo Mountains in New Mexico. Oh yeah, you see the exact same thing, which is really just an extension, further south from Colorado.
Yeah.
Um, I've actually visited Boulder many times, so I am familiar with that region somewhat. Um, but that's all part of what used to be, used to have beachfront property there, if you will.
Yeah.
Before the Rockies were uplifted and all that kind of stuff there. But I know Wally Broker looked at a huge inland freshwater sea in the prairie provinces of Canada, and that dam let loose and dumped all the water into the North Atlantic, and that helped bring on a bit of a ice age as well, because you had this influx of fresh water. And I forget,
Interesting.
and
Do you know
that
when
I think
that
was
ice dam
I think that was the Little
existed?
Dryas era.
Yeah, and that was also the same time that there was a big inland lake, interglacial lake in
Right.
Lake Missoula that broke loose probably about 12,000 years ago or so. We don't know exactly when it was. And that is actually the one that flowed west and it created the dry falls in eastern Oregon. Have you ever seen those geological structures? Do you know what I'm talking about? And that was all
Not in Eastern Oregon. No, I haven't been there.
yeah. And that was all breaking loose, not necessarily just from Lake Missoula, but a series of ice dams that broke that were a consequence of the extreme melting that was happening at the end of the last ice age. And it really carved the land, sculpted it, and created the Badlands.
Yeah.
Actually, also in that area. So it's fascinating to
Well,
know
I've
about
been
these
through
extreme
the
geological
Badlands of
changes.
South Dakota up into Drumheller, Alberta. So I've been that way. But keep in mind, those were freshwater. We're
Hmm.
talking, about intrusion of saline water.
Hmm.
That I think we go further back in time to, as I
Hmm.
said, the Jurassic era, when
Yeah,
North America was split in two by the
yeah.
inland ocean.
Yeah, and I think there's no danger of that happening this time because the extreme geologic uplift. I mean, we're only talking about maximum about 200 feet of sea level
Right.
rise all told. So we're not looking at anything like that. But we are looking at places that are completely flat and on kind of a limestone base, like Florida, for example, right? Florida is a very, very vulnerable place because it's
Yeah.
all on, this kind of calcium limestone structure that's very permeable. And, those poor people are going to have a big, big problem.
And not only that, if the oceans are becoming more acidic, well, acid and limestone makes a great combination to put things into solution.
Oh my God. We're just looking at a bunch of disaster, I'm afraid.
I mean,
With that,
but that is something people need to keep. It's not just the coastal areas that are at risk. It's wherever there's a major river. This includes the Amazon, the Anadir, whatever. Wherever there's a major river flowing into, the rising sea level is just going to rush that right up there, and it'll just flood wherever the drainage basins of those respective rivers. That's a major problem waiting
absolutely.
to happen.
Ugh, very scary stuff. Um, if you don't mind, I'd like to go on to our next article, Sandy,
Sure.
if you could bring up the California wildfires spawn first gigafire in modern history. This
You
is something
got
that
it.
came out in The Guardian on the 6th. That was a very nice voice, Sandy. Thank you so much. The 6th of October. And we've got a new term on our hands, guys. It's the gigafire. So let me just kind of read through a little bit and then we'll have a little discussion. California's extraordinary year of wildfires has spawned another new milestone, the first gigafire, a blaze spanning 1 million acres in modern history. On Monday, the August complex fire in Northern California expanded beyond 1 million acres, elevating it from a mere megafire to a new classification, gigafire, never used before in a contemporary setting in the state, probably anywhere else either. At 1.03 million acres, the fire is larger than the state of Rhode Island and is raging across 7 counties, according to fire agency CAL FIRE. An amalgamation of several fires caused when lightning struck dry forests in August. The vast conflagration has been burning for 50 days and is only half contained. The August complex fire heads a huge list of fires that have chewed through 4 million acres of California this year, a figure called mind-boggling by CAL FIRE and double the previous annual record. 5 of the 6 largest fires ever recorded in the state have occurred in 2020, resulting in several dozen deaths and thousands of lost buildings. Very sad. There is little sign of California's biggest ever fire season receding. The state endured a heat wave this summer, aiding in the formation of enormous wildfires, even without the seasonal winds that usually fan the blazes that have historically dotted the West Coast. Fast, out of control fires are increasingly a feature in the U.S. West due to climate crisis, scientists say, with rising temperatures and prolonged drought causing vegetation and soils to lose moisture. This parched landscape makes larger fires more likely. Big wildfires are 3 times more common across the West than in the 1970s, while the wildfire season is 3 months longer, according to an analyst by Climate Central. Quote, "We predicted last year that we were living with the chance of such extreme event under our current climate," said Jennifer Balk, a fire ecologist at the University of Colorado Boulder. Yay, Boulder! Don't need a crystal ball. The 2020 fire season has caused choking smoke to blanket the West Coast and at times blot out the sun. But experts warn this year may soon seem mild by comparison as the world continues to heat up due to the release of greenhouse gases from human activity. If you don't like all the climate disasters happening in 2020, I have some bad news for you about the rest of your life, said Andrew Dessler, a climate scientist at Texas A&M University. They're all becoming We Are So Fuck Doomers. That's amazing. Parts of California are expected to receive some relief this week, with temperatures in Northern California dropping up to 15 degrees Fahrenheit by Friday, according to the National Weather Service. Meteorologists are forecasting some light into moderate showers, blah, blah, blah. So it kind of continues. And I think that the point of this is it's going to get worse. And this is tragic beyond all reckoning, beyond all expectation, beyond all imagination. And it kind of sounds like hang on to your hats because these are the good old days. What do you think of this, Jim?
Well, it's alarming to say the least. You have several things at play here, and all that leads to basically increasing the positive feedback loops, whether it's the fires, the ice melt, or the lack of sea ice, the sea level rises. We are seeing positive feedback loops basically hitting warp factor speed at this point. I mean, it's gone out of impulse. It's now in warp factor, and
Unbelievable.
and so it doesn't surprise me, because if you're warming up the atmosphere, warmer atmosphere can hold more moisture. But if the area is already dry to begin with, then guess what? It's going to suck the moisture out of the ground, and that makes the ground drier. And if it makes the ground drier, it makes the ground more vulnerable to fires. And I've done many videos where they say dry areas will get drier, wet areas will get wetter. The other thing is that it would not surprise me if the fire season in California becomes year round. Now, we talked about a blue ocean event plus 10. Okay.
Yeah.
Let's talk about a fire event plus 10.
That's just too scary even to contemplate. That's the end. I mean, there's no relief. And even this morning, you know, I haven't heard of any big fires going around here, but even this morning I could smell all the smoke in the air. And I don't know if you have any fires up where you are, but it's strange to have this pervasive smoky smell in the air, you know, week upon week.
This year was one of the lowest fire years in Alaska. But last year there was a fire less than 20 miles from my house.
Oh.
And let's not forget, you know, the holdover fires, that they don't burn out completely during the winter. They still smolder on the ground, and then basically waiting to go, you know, bang, go right back up again. You know, so you still have those issues. Even if there is snow cover, it can still smolder underneath it, which is, to me, is really like, you know, just like, wow. Just it's very hard to get my mind wrapped around that. Now they're talking about here, you know, might get some relief. There's another thing that factors into what's going on, and that's basically the ENSO and the Pacific Decadal Oscillation cycles. Right now, this year, it's been basically verified. We've moved into a La Nina situation.
Mm-hmm.
La Nina has cooler ocean, equatorial oceanic waters in the eastern Pacific. So that will tend to bring cooler conditions to, you know, the lower, southern western coast of the U.S. into Mexico. Cooler conditions are good. You have cooler temperatures, can help tamp down the fires. Usually, though, you don't get as much precipitation with the La Nina as you do with an El Nino, but El Nino is a warmer situation. So there's kind of good and bad from whether you're in the El Nino's part of the cycle or the La Nina part of the cycle. But this is still going to affect what happens with the oceanic temperature, will affect precipitation, and then you can affect the flow of wind patterns, that kind of stuff. So it all ties in.
Mm-hmm. Well, it's pretty shocking how these fire seasons just continue to expand and expand. And, you know, it's very, very devastating. It's scary.
It is. And when you think about how dry the ground is, add in some holdover fire, it really doesn't take much to set these things off again.
Yeah.
And think what that's going to do to agriculture. You know,
yeah.
California grows a lot of important crops.
Well, listen to this. In the Central Valley, it's under an air quality alert. That's where most of the vegetables are grown, right? Because of wildfire smoke from the Creek Fire, which has burned more than 326,000 acres, and the SQF Complex Fire, which has burned nearly 159,000 acres in the Sierra National Forest. Northwest California, where the August complex fire rages, had air quality in the unhealthy to locally hazardous category as well. Meanwhile, coastal swaths of the state woke up to dense fog on Tuesday, a confusing contrast to the smoke-filled haze that many had got used to seeing during the peak of the wildfires. I heard my auntie say that she lives in Marin County, and she was saying basically the marine layer came in and pushed under the smoke, and it actually kind of sheltered her in Marin County, just the fog marine layer, because the smoke was on top of that.
Can I interject for a minute, guys? We're going on. It's a great show because I'm having a great time listening and learning and helping. But we're going on 47. So what I want to do here is just make you guys aware. Keep going, but people are going to have questions towards the end of the show, and I've asked everybody to put 2 question marks after any question you'd like me to read to you guys. Okay, so there you go, and have fun. Finish up. Bye, guys. I'm still here.
Okay. Thanks, Sandy. We appreciate it. Well, with that timekeeping in mind, let's go ahead and move on to our last article very quickly and go through it, and then we'll take a couple of questions. So this is one about Exxon. Thank you very much, petroleum industry. Exxon is planning to pollute way more in the coming years. Leaked documents show. This came out on October 5th, 2020, and I'll just read a couple of the first paragraphs and then we'll have a discussion. The window to reduce carbon emissions in order to avoid the most disastrous effects of climate change is getting smaller by the day. It's such an obvious extinction level problem that even most oil companies have been at least saying the right things and committing to a reduction in oil extraction and dirty burning fuels. ExxonMobil, however, appears to be taking the opposite approach. According to internal documents obtained by Bloomberg, the oil giant plans to increase its annual emissions by as much as 17% over the next 5 years, adding 21 metric tons of carbon dioxide to the atmosphere each year. Sucks. Bad. Exxon's apparent planned ramp up of carbon emissions is part of a $210 billion investment strategy that the company put into place in 2018. And it's really only a fraction of the damage to the planet that the company will be responsible for. The projected 21 million metric tons of new carbon emissions account only for direct operations, which include things like drilling for oil and extracting and transporting the fuel. Bloomberg estimates that the emissions from these efforts account only for 1/5 of the company's overall carbon footprint, with the majority coming from consumers burning the fuels. It is estimated that the company will actually be responsible for closer to 100 million tons of additional carbon emissions each year when fuel use is accounted for. Damn, this is just depressing. The result of all these new emissions is the equivalent of plopping an entirely new developed nation on the planet. ExxonMobil, Bloomberg calculated, will be responsible for emission levels that are similar to the entire country of Greece. The company would produce just as much greenhouse gas if it built and powered 26 coal-fired power plants. Put simply, ExxonMobil is adding a whole heap of new emissions at a time when it should be attempting to shrink its overall carbon footprint. Damn. I'm not going to read the whole thing, but I think we know where this one's going. Jim, it's so depressing that they're just so committed to our demise, and that they've known for climate change pretty much longer than almost anybody, as there's evidence that ExxonMobil was conducting carbon dioxide studies back in the late 70s. How does this make you feel to hear about the plans that ExxonMobil has for us?
Basically, what ExxonMobil has just done to human civilization is given us two big, huge middle fingers.
Yeah,
That's what it did.
exactly.
I mean, we have the email evidence from as early as 1974 that
Yeah.
they knew adding that CO2 is a greenhouse gas that will increase global temperature. They knew back then. They decided to just continue to put that waste product into the atmosphere through the burning of the fossil fuel. They chose to continue going down that pathway. Then you add in the war on climate change, all the deniers and the so-called skeptics, as if it's based on actual data, okay? But this whole propaganda BS that they put out, and yeah, we're in this crap that we have today. So this is absolutely criminal in my view. This is Tom Engelhardt over at Tom Dispatch. He coined a term about a decade or so ago. He called it terrorcide, TERRACIDE. And he said they're basically embarking on terrorcide. And he's right. I just read an article somewhere, it might have been Eco World or whatever, where Exxon's planning to like flatten, bulldoze all these areas in Indonesia, all these important swamp areas that are filtration, a natural filtration system. They just want to bulldoze it over to get to the fossil fuels. It's absolutely criminal. And the disgust I have for this, well, let's just say I can't begin to relay how pissed off I am.
It's deplorable. It's inexcusable. It's disgusting. It's against life. It's anti-life. And so they look better on their bottom line for the next year. Well, eventually they're going to cause the extinction of their own company as the whole world goes down as well. And they're going to be responsible directly for contributing to the debacle and the demise and the death of the biosphere.
I did a video some time ago where I discussed about this Australian conservative think tank looking at everything, and they made the assessment that there's not going to be human civilization by 2050. That's 30 years away, less than. And now that I'm seeing all the data coming in, just looking at the science and drawing making the assessment that we're past the tipping point as things are, if Exxon then throws this into the mix, well, you talk about an exponential increase. Well, you might as well, kick up the base used to a higher base. You might go from base 3 to base 7 or some darn thing like that, because this will definitely bring on the end of human civilization in a very short working order.
Yeah. They've never shown any interest in making promises to reduce their carbon footprint. They've never set a date to reach carbon neutral status. And it appears that their MO is just to continue operating as if the planet is not on fire. But it is on fire.
It is. And, why are they doing all this drilling? Why? Very simple. Capitalism. Because capitalism, money, all that matters is continued growth, and you can't have continued growth with finite resources on a finite planet. You just can't. If you didn't have a capitalistic system, I don't think they'd be pushing for this.
Yeah.
I'm
No,
not an
it's
economist, but I'm just
it's
saying.
very depressing. It's just very depressing that they're completely on board with driving down and contributing to the extinction in a giant way. I find articles like this kind of depressing. It makes me feel kind of hopeless, actually, and mad. Uh,
Angry. Angry.
Yeah,
yeah,
it's
it does.
Would you guys like to
but
do questions?
Yeah, let's have
it
some
is the state of
questions.
things. So
Okay,
It
well,
is the
we've
state
lost
of
Jim,
things.
and I guess I'll stay on for a couple of minutes here. And there was some good ones. I'm going to go back and guys, here's one. Garrett. Garrett asks, what is a good response when someone blames depression, psychology, when you attempt to explain the dangers here? Jen, you want to take this one?
Oh, I see. Yeah, absolutely. So I think that what he's talking about is it's not healthy for people to put out information that leaves one in a hopeless state. Is that kind of what he's saying? Yeah,
I would think so.
I mean,
Yes. Or and
yeah,
Garrett, I would say yes. What's a good response? And when they blame depression in psychology, when you attempt, they don't want to handle it. People need to have skills to handle, and they're not getting those
yeah,
skills in education in the education
yeah.
system
Well,
because there's so much denial. Okay, let me
yeah,
find.
yeah. It's
Let's see. We had some good ones, and I'm just going to be a second. Good evening, Suzanne. Suzanne's here, Captain Nemo, Rich, Diana. Thank you, everybody, for helping us out. Here. Well, of course, Gary. Gary, thank you for coming. Gary is over from. Again, I'm so happy he's following us from Nicole Sandler's show. Gary, so will a warmer northern Atlantic cause any additional problems? Jim?
well, here's the kicker. The northern Atlantic right now, if you look at the northern Atlantic in the Jin Sea area, is actually cooler because of all the freshwater melt from Greenland is actually keeping the oceanic surface temperatures cooler. However, you are having an intrusion from deeper layers of North Atlantic water, coming up from mid-latitudes. And this North Atlantic water that's making its way into the Arctic region, North Atlantic, is now making its way to the surface. So we are in certain locations, depending where you're at, you are starting to see a slight warming. In addition to sun energy, where there's no sea ice, you're seeing some warming. As we discussed earlier with the ice, you're warming the ice with the increasing air temperatures from above and the warming oceans from below. Well, same thing happening in the Arctic Ocean and like past Franz Josef Land, where you have an upwelling of North Atlantic water that is warmer, so it can bring warmer. But if you go over to the Jin Sea, off eastern Greenland, all that freshwater melt is in that localized region. The North Atlantic is cooler, surface temperature wise. So you got a whole bunch of crazy things going on. The Barents Sea, as an example, is being what we call Atlantified. So if you look at the physical and chemical properties of the Barents Sea, it's looking less and less of an Arctic Ocean signal and more of a North Atlantic signal. We're seeing higher salinity, warmer temperatures.
Wow.
So it depends where you're at.
Okay. Well, thank you. I'll just throw this one up in the air, and then whoever grabs it first. Hoople's Cat from Canada. Thank you very much. And Hoople's Cat made a donation toward our microcell tower. Thank you. Is there anywhere not affected in 2020 by human-caused climate change?
wow.
No,
Yeah. Kind
no,
of a Jenish
no.
question.
Well, I'd just like to kind of, the article that we didn't get to, and we're not going to read it right now, but just to give you an idea, there's a
Hold up.
record of 16 climate disasters that have hit the U.S. in 2020, costing more than $1 billion
Let me
each.
pull it up.
The first 9 months of 2020 are tied with annual records of 2011 and 2017, with at least 2 more months of hurricane and wildfire seasons to go this year. So the climate cost is going up, and it's probably, like everything else, I would imagine, going to go up exponentially. Now, that being said,
sadly,
I mean, there are some places that are not
the
as...
only way politicians are going to ever get off their doofus is if we start waving the economic costs in front of them. You talk science to them, you talk, the logical policies that should be pursued. They don't care. When they will start caring when it's costing money, when it's costing jobs. Then say, oh, maybe we need to do something. Well, you know what? It's already too late.
Yeah. Exactly. And there's a little map, Sandy, if you can include this link in the show notes of that one from theindependent.co.uk, because it does show where the big climate disasters are, and you could just bring those up and you can see there's a fire for all the big wildfires that have been happening. And I just lost it because I went too big and I lost it.
I got it.
But
it's coming up.
It's pervasive pretty much throughout the United States, with some notable kind of hot spaces, with tornadoes,
but they won't
hurricanes, thunderstorms,
won't let me,
floods, fires.
And what's that new phenomenon? Was it derechos? Which is basically horizontal tornadoes that stretch for tens and hundreds of miles. It's sort of like a rolling, just a rolling mass of air plowing through things.
You ain't seen nothing yet. This is going to be totally like James Hansen's Storms of Our Grandchildren is happening now.
There was, let's see, Jennifer, I know there was somebody that asked for Jim to say, Jim, do you have a BOE prognostication? I mean, I'm sure everybody asks you.
I'm not in the habit of making predictions, but is a BOE coming down the pipe? I would say the data indicates very strongly that the answer is yes. And will the BOEs then persist in duration during the year? I will again say the answer is yes. Time frame? Well, when we say BOE +2, +5, +10, I don't say that's set in stone, but it's kind of as a guideline. But the indications are that yes, we will see ice-free Arctic Ocean.
Okay, and the next question, where's all that water going to go? Suzanne. Jen?
You mean with the sea level rise?
Where's it going?
Is that what she means?
Yes, I know that's what she means.
I mean, the first thing that we're going to see with sea level rise is the ports, right? So every port is built at sea level, with all the cranes and the things that take the cargo off and the things that unload the oil. They're all built at sea level, and as the sea level rise continues to escalate, those ports are going to become submerged. There's a lot of infrastructure that's exactly at sea level that's going to become submerged. The nuclear plants that are at sea level, like Turkey Point in Florida, that's going to become submerged. That's very, very scary, and that's going to just exacerbate the whole thing. Of course, as we mentioned, Florida is going to get saltwater intrusion. So a lot of the infrastructure, because a lot of the very key cities are built on ports and infrastructure, naval ports, shipping places. I mean, those things, that infrastructure is going to get flooded. So it's going to be a very scary time.
As I discussed earlier, it's not just going to be coastal areas. Wherever you have a major river drainage basin system, the basin is all, of course, depends on how much the rise is, but that's going to get flooded. So there will be less land. So there's going to be less real estate. And then you're going to have all these climate refugees, but now you're going to try and take the same number of people and have them live on ever decreasing available land, putting even more pressure on the land to raise food for housing, that kind of stuff. And if you've got saltwater intrusion that's going to kill your crops, you're going to have famine and starvation resulting. So this comes down to carrying capacity and all this other kind of stuff I discuss a lot. But you're going to have those added pressures on the system, and it's just not looking good.
It's not looking good. And a place that saltwater intrusion's really critical for the food supply, Jim, is in the Mekong Delta in Southeast Asia. That is a particularly fertile, huge, giant, flat plot of land, ideal for growing rice. And every year, that area in the Mekong Delta, which is pretty much dedicated to rice production, is producing less and less rice, and that land is getting intruded with salt.
To feed
that
more
area
and more
will,
people.
if the sea levels increase as the projections are telling us, that area will be swamped. And as far as producing less rice, what we're also seeing is that the nutritional quality of the food is less as well. So not only is there less food being produced per acre, but the nutritional value has decreased.
Okay. Snork had this one. But I don't know. Are there any problems from southern waters? I'm not sure exactly what he meant. And if he wants to get a little more clear, I have a really good one from Dee Dee. Dee Dee Sunbeam says, is it possible for California, Oregon, Washington to use controlled burning? Or is it too late to start that up again because of the undergrowth and the amount that would have to be burned?
Well, the amount of people that are building and living within these forested areas has gone up like 700% since the 1980s or something. I mean, everyone's just moving it. So it becomes very difficult to do controlled burning. I'm not really an expert on this topic. What do you think, Jim, about this?
I'm not an expert either. I mean, I just jokingly say I go splash in the water a lot, but considering how dry everything is, if you try to do controlled burning, how much control does one really have? And it probably wouldn't take much for it to get out of control. So
exactly. I mean, how many fires can you envision being started by a controlled burn in a very, like, if it's particularly tinder dry with wind, that thing could get out of, I mean, you could start whole forest fires that way. So I don't know. It's difficult to maintain the fires and do controlled burns. It's very kind of like surgical.
I'm in agreement with you because it's just too many. It's like everything else. There's always parameters with the interactions that we never know about that can set things off on a course of results that were never even contemplated. So it's just.
Well, let's go on to Snork. You know Snork, Jim. At Y2K. Snork Y2K. Mitchell. Isn't 140 mile per hour, 700 mile storm more of an inland Cat 4 hurricane than a tornado? Now, he had asked the southern water question, so I don't know if this is more a meteorological question that would be good for Nick Humphrey. What do you think?
What's he asking again?
Isn't a 140 mile per hour, 700 mile storm more of an inland Cat 4 hurricane than a tornado? But he's got that in quotes, so I was assuming he was trying to ask something.
You would have to look at the actual features of the storm in question. I'm not sure. I am not aware of tornadoes being 700 miles in width. that would fall into the category of a cyclone. I mean, I've heard of tornadoes being several miles in width, but not several hundred.
Wow.
So there's a couple orders of magnitude difference right there. 140 miles per hour. That's on the upper end of a Cat 4. So sure, if you want, if it's a hurricane, that would fall into that category. I actually think that we need to create a Cat 6 category for the simple reason we're seeing some storms that are exceeding 170 miles per hour.
Wow. All right. Wait.
Yeah.
I was just
Especially some of those typhoons out in the Pacific.
Okay, Dee Dee. Here she got another one. Do you see human extinction as early as 2050, especially if the methane bomb goes off? That's another one of those tough ones.
Well, let's put it this way. Putting aside all the shit that's being done to the planet by human activity, the very fact is there's just simply too many people on the planet for available resources to be sustained in a renewed manner. So a corrective measure has to happen. That's basic ecological principles. The virus that we're all dealing with is one such corrective measure. Losing, people starving is another corrective measure. And, if you get whatever politician that gets his or her knickers in a knot and goes and starts off wars, that is another corrective measure. So will this lead to human extinction? Who knows? But it would not surprise me if there was a massive die-off of people, and even 75% of the human population dying off within the next several decades would not surprise me. I hate to say that, but just looking at the situation, and just sticking to the science.
Absolutely.
I see that as a real possibility.
I would say that we're in such a profound time of dissolution and demise and huge apocalyptic change. And, I would advise people not to be breeders. If you've already bred, so be it. But, try and encourage your children to not be breeders. Seriously. I mean, there's untold misery probably going to afflict the human race at large.
Call us eugenicists.
And we are living in the good old days. So don't be a breeder. Be happy for the moments that we have now. I guess that's kind of my very depressing point of view.
No, it's not.
The only children I ever had were the four-legged variety.
Yeah. Well, listen,
and
guys.
They were all rescues. They were all rescues.
Oh, that's awesome! Like my cats are all rescues.
I have a rescue also. I have a rescue too, and she's so happy. The rescues are so happy. My little kitty cat, I got her about 3 months ago, Amelia, and she was in the pound for about 2.5 months, and so grateful to have a home and a family again. So
yeah, and so are my 5. But what I wanted to do was for you guys was read Hoople's ending. I mean, I think this is a good way to end. We're going on an hour and 15. These are all symptoms, though. The real issue, as Jim said, is we have exceeded carrying capacity and are now seeing the results accelerate. I think that's really a good way to go out. What do you guys? I'm going to give you guys a last. It was your show. I'm just here reading the questions, seeing if there's anything else.
This is what science is. We may not like what it tells us, but you can't change the laws of physics and chemistry, and there are certain scientific concepts and principles that have been well demonstrated and have I don't want to say proven, but have been demonstrated to be upheld very closely. And carrying capacity is one of them. There's a specific heat and other thermodynamic considerations, if you will.
Yeah.
Well,
science rules.
Yeah, science rules. Awesome show. Thank you guys. Jen, I'd like you to say goodnight, and I really enjoyed this with you and listening to you and having you and doing all this. And guys, don't forget we're having our fundraiser, and we've never done anything like this before, but as you see for yourselves, I run the channel. The internet is horrible, and whatever you do for us, we will really appreciate it to get a microcell tower so we can continue bringing fabulous information that not a lot of other people do in the way we can do it, and just get better at it. So thank you, Jim, and thank you, Jennifer.
Thank you, Sandy. Thank you, Jen.
Yeah.
Great combo.
Thank you. Thank you, Jen. Thank you, Sandy. It's been a great show tonight. I'm so happy that we got this time to spend together and talk about these very important issues currently going on.
And, while the tone is extremely sober and can be depressing, we would be doing a disservice if we tried to say it isn't what it is. What we're sharing with the folks is this is what it is, folks. And only that harsh reality can hopefully spur people into taking whatever actions and steps are necessary to at least mitigate. I don't know if we're going to stop it, but we can at least mitigate, try and make as habitable as possibly enjoyable a world to live in.
Yep.
And
as a friend of ours says,
but this is what it is. It ain't pretty.
Smoke 'em if you got 'em.
There you go.
Farewell, everybody.
Anyway, it was really great chatting with you guys, and good show.
All right. Good night. Peace.
All
and
right.
thank you.
Peace.
Dobry wieczór.